There's one question I get asked all the time. Vinay, be honest. Is it a mistake to become software engineer right now? And I get why. In 2024 alone, over 400,000 tech jobs were cut globally. And at the same time, AI is writing code faster than ever. I hear this from students, professionals from other industries, and even friends, all wondering if it still makes sense to enter the field in 2026. And it's a fair question. It's a massive career bet. You see an AI generate a fully functional app from a single text prompt. You read about tech layoffs, and it's completely rational to wonder, am I about to bet my future on a sinking ship? My name is Vinay Bansal, and as an engineering manager working at top tech companies like Google, I have a front row seat to this transformation. I can see what's coming next, and I can tell you the panic is understandable, but it's focused on the wrong things. The role of an engineer isn't disappearing, it's evolving something into much more powerful. In this video, I'm going to give you the insider's perspective. We're going to talk about why now might actually be the most exciting time in history to build the future. Alright, let's tackle the fear head on. The core anxiety is this: if AI can write code, why would a company need to hire a human coder? This fear comes from misunderstanding what software engineers actually do. For years, we have confused the tool with the skill. Code is just an instruction manual. The real skill has always been problem solving, understanding the problem, designing the solution, and guiding the tools to build it. AI is getting incredibly good at writing that manual, but it has no idea what problem it's trying to solve or why. It can't talk to a user, understand their frustration, or design a creative solution to make their life better. It can write the manual, but it can't write the story. Your value as a future engineer isn't your typing speed. It's in your ability to understand a human problem, design a logical solution, and then guide the tools, including AI, to build it. The person who can only translate instructions into code might be in trouble, but the one who can architect solutions is about to become more valuable than ever. To understand this, we don't need to look at the future, we need to look at the past. Think about a genius like the great Indian mathematician Srinivas Ramanujan. In the early 1900s, he filled notebooks with thousands of profound theorems, all worked out by hand. His mind could solve patterns in the universe that nobody else could, but his genius was limited by the speed of his pen. The sheer effort of manual calculations consumed his time. Now, imagine if we could have given him better tools. First, a simple calculator, then a personal computer. Fast forward to today, imagine giving Ramanujan access to a supercomputer that can perform billions of calculations in a second. What problems could a mind like his would have solved with that kind of power? This is the journey we have been on. We built progressively powerful wrappers around the hard work of calculation. This is how we achieve incredible feats. It's how we can send a spacecraft like the Mars orbiter all the way from Earth to Mars and know exactly where it will be months later to enter the orbit. The calculations for that journey are so complex, it would have been impossible to do by hand. We didn't replace the brilliant minds. We armed them with tools that let them work on a level their predecessors couldn't even dream of. And this story is the exact story of software engineering as well. Think about it. 50 years ago, we had assembly language. This was like having to talk to computer in its native robotic language. You had to manage every tiny piece of memory, every single calculation. It was incredibly slow and difficult. Only a few specialists could do it. So, we built a better tool. We created high-level languages like Java and Python. This was a huge leap. You could now write instructions in something that felt closer to English. You didn't have to manage all the low-level details. The tool handled it. And did this kill programming jobs? No. It created millions of them because now more people could build software, and the software they built was more ambitious. But that still wasn't easy enough. So we built frameworks and libraries. These are like pre-built toolkits. Need a user login page? Don't build it from scratch. Just use the login toolkit. This made development even easier and faster. Then we created the cloud. Google Cloud, Amazon AWS. You no longer need to be an expert in managing physical computer servers. You could just press a button, another layer of complexity gone. Now, look at the pattern. At every single step, the work just got easier. And at every step, people panicked. They said, if the framework writes half the code, is my job safe? And every time, the exact opposite happened. The easier it became to build, the more we built. The demand for great engineers exploded. AI is not different. It's the most powerful toolkit we've ever had, the one that frees you to be the mission director planning your own mission to Mars. So, if AI handles more of the how part, you get to focus on the what part. And the what part is becoming incredibly exciting. For decades, engineering was about building things on screen like websites, apps, business tools. That era is ending. Software is breaking into physical world and AI is the key. Think about the new frontiers that are opening up right now. Frontier number 1, engineering biology. For the first time in history, we can treat biology as a programming problem. Companies are using AI to design new life-saving drugs, to create personalized cancer treatments based on patients' DNA, and even to invent new proteins that have never existed in nature. This isn't science fiction. It's happening right now and it's being led by engineers who can think in systems. Frontier number 2, the physical world. Look at robotics. For years, robotics were limited to simple repetitive tasks in a factory. They were strong but not smart. AI gives them a brain. This is creating a massive demand for engineers who can build intelligent systems that interact with the physical world. Self-driving trucks, automated warehouses, robotics that can assist the elderly. All these are fundamentally software problems. Frontier number 3, scientific discovery. We are generating more data than ever before, from climate science to astronomy. The problem is, we can't make sense of all of it. AI gives us the ability to find the needle in the haystack. Engineers are now building AI systems that can help scientists find new materials for batteries, create more accurate models of climate change, and even search for signs of life in deep space. These fields are where the most impactful and highest paid engineering jobs of the next decade will be. And they all require a skill set that goes way beyond just writing the code. So, if you are convinced this is a world you want to be part of, what do you do now? How do you prepare for this future? Here is your 3-step action plan. This is what I tell every young engineer I mentor. First, master the core principles. Tools will keep changing. Frameworks, languages, even AI itself. But the fundamental principle stays the same. How do computers actually work? What are the data structures and algorithms? How does the internet really move data around? This is the bedrock. This knowledge is what allows you to adapt. When you understand the fundamentals, you can pick up any new tool quickly because you understand the why behind it, not just the how. Don't just learn to code. Learn how to think like an engineer. Second, use AI as your personal tutor. The biggest mistake you can make is using AI to do the work for you. The smartest students will use AI to learn faster than everyone else. Don't ask it to write your code. Ask it to explain a complex topic in 5 different ways. Paste in a piece of code that you don't understand and ask it to explain line by line. When you get an error, don't just ask for a fix. Ask it why that error happened and what the underlying concept is. Use AI as an accelerator for your own learning, not a replacement for it. Third, build a portfolio of problems, not projects. In the past, you could get a job by showing you built a clone of a popular app. That's not enough anymore. AI can do that in minutes. You need to show that you can solve real problems. Find a problem in your own life, at your university, or in local community. It doesn't have to be big. Maybe the system for booking study rooms is terrible. Maybe a local charity needs a better way to track donations. Go through the whole process. Talk to the users. Design a solution. Use AI as a tool to help you build it faster. This shows employers something an AI cannot. That you have the initiative, product sense, and the drive to solve real-world problems. That is a skill that is and always will be in high demand. So, should you still become a software engineer in 2026? If you define an engineer as someone who just translates tickets into code, then maybe not. That job is getting automated. But if you define an engineer as a creative problem solver, as an architect of systems, and someone who uses technology to build a better future, then there has never been a better time to start. The tools are getting better, the problems are getting bigger, and your potential impact as an individual is growing exponentially. You are entering this field at a moment of incredible leverage. So my advice is simple. Don't be afraid of the future. Be excited by it. Find the frontier that fascinates you. Double down on the fundamentals. And as I always say, aim to be top 10 of whatever you choose to do. Future isn't going to build itself. We are waiting for you to build it. If this video was helpful, please hit the like button and subscribe button. I read all the comments, so feel free to ask any questions below. Thanks for watching, and I'll see you in the next one.